All right, example 1, we want to graph the function x minus 1 over x squared minus 4. I'm going to start by filling in all of the information, and then we will graph this as we go along. So first thing, when we want to use the RATEY method, the function has got to be factored. And so I'm going to start by factoring this bad boy, x minus 1 over a difference of squares, which is going to give me x plus 2 and x minus 2. And so I notice that nothing here is going to cancel out, and so what that means is that I am not going to have any holes. Roots come from the numerator equaling to 0. So your numerator is x minus 1. If you set that equal to 0, you're going to get the point 1 comma 0. And so over here at 1, 0, we are going to plot our one and only root, meaning that is the only place that we are allowed to cross the x-axis. Now for vertical asymptotes, those occur when the denominator is equal to 0. And so looking at the denominator, when does that equal 0? X is equal to positive and negative 2. So over here at negative 2, I'm going to have a vertical asymptote. And at positive 2, I'm going to have a vertical asymptote. Okay. Tangency and togetherness. Now, this is one thing that students sometimes mess up if they're not careful. If you are looking at the unfactored version, you are going to look at that square right there and think that you see multiplicity and tangency or togetherness, but you have got to look at the factored version of this and notice that neither of these factors have a multiplicity that's bigger than 1. Both of those do not have a squared, and so therefore there is no tangency or togetherness. And so really when I write not applicable there, I'm really saying something about that. I'm saying that at both of my asymptotes I am not together, and I'm saying that at my root I am going to cross through the x-axis. And so you could write that here if you wanted to. You could say at 1, 0 I'm going to cross, and at x equals plus or minus 2, the graph is going to be not together. You don't necessarily have to write that, but it might be a good idea just as you're getting started. Now for E, our end behavior, our horizontal or oblique asymptote, it's usually easier to look back at the original function. And so if I just erase what I've got here, the original function, the unfactored version, is bigger on bottom, and so that tells me that I am going to have a horizontal asymptote. Bigger on bottom means that it's going to be at y is equal to 0. So here at y equals 0, hopefully you can see that. I'm going to put a horizontal asymptote. And then finally, the y-intercept is going to be when x is equal to 0. Again, easier to do whenever you look at the unfactored version. And so if I let the x's be 0, that's going to be 0 and positive 1/4. And so 0 and positive 1/4 is going to be a point that I'm going to plot. Now, from here, we've got to fill in the puzzle pieces. We have 2 vertical asymptotes here and here. That means the graph is going to have 3 sections, 3 separate pieces to this graph. One over here to the left of the first asymptote, one in the middle here between the 2 asymptotes, and one over here to the right of that second asymptote. And there is no real, hey, do this every time. It's really just going based off of what you have, and sometimes it is a matter of trying something, and if it doesn't work, trying something different. That's why God made erasers, is for you to mess up and try it again if it doesn't work. And so I'm just going to try something here and just see what happens, and I'll use the laser pointer. I'm going to start in the middle here. And so what I know is that if I start just to the right of this asymptote, I'm either going to come up this direction or come down this direction. Okay, well, if I start by going up here, I know that I'm going to have to pass through that y-intercept. Well, if I come up, in order to get to that y-intercept, I'm going to have to cross through the x-axis somewhere here. But I can't do that because I don't have a root there. The only root that I've got is 1, 0 right here. So I know that I cannot come up this direction. That means I've got to come down the other side of this. And so I'm going to come down, I'm going to come to that y-intercept, go through that y-intercept, and go to my root. I remember that at that root, I'm actually going to cross through the x-axis, not bounce or be tangent. So I'm going to cross through and go down towards that other asymptote. Now, the fact that I've got those that piece successfully put in there means that the other two pieces are going to be pretty straightforward, because I know that I am not together at the other two asymptotes. And so for the section over here to the left, can I draw my piece right here? If I do, what's going to be true about that asymptote? Well, it's going to be together, and I cannot have togetherness at that asymptote. Therefore, I cannot draw that section above the horizontal asymptote. It's got to be drawn below the horizontal asymptote down here. And then on the right-hand side, basically the same story. If I try to draw it down here, I'm going to have togetherness at x equals 2. But look back at the information. We didn't have togetherness at x equals 2 because there's no multiplicity on that particular factor. And so I'm not going to be able to draw it down here. In order to be not together, I'm going to have to draw my graph up here, and it's going to have to look something like that. Okay, here again on example 2, we're going to have to factor before we can start using the RATEY method. And so the numerator is taken care of. It's just x squared, but the denominator is going to again factor as a difference of squares into x plus 4 and x minus 4. So notice nothing's going to cancel, so I'm not going to have any holes in this particular function. The roots come from the numerator. So when the numerator is equal to 0, that would be the point 0, 0. And so I'm going to go ahead and plot the origin there as one of the points on the graph. Vertical asymptotes occur when the denominator is equal to 0, and we write our answer as x equals a number, which in this case will be plus or minus 4. So at x equals negative 4, I'm going to have a vertical asymptote. And at x is equal to positive 4, I'm going to have a vertical asymptote as well. And hopefully you can see the negative there on that first 4. Tangency and togetherness. So do I have any squared terms in the factored version? The answer this time is yes. We are going to have tangency at the root because I see that there is a square in the numerator right here. So we are going to be tangent at the root 0, 0. So what that means is that the graph is going to bounce back either down or up, depending on how it started, off of that x-intercept. You're not actually going to cross through the x-axis at your root. End behavior is much easier to determine from the original version. So if I look at the unfactored version, I've got x squared divided by x squared. The exponents there are the same, and so I'm going to divide the coefficients to get y equals 1 as my horizontal asymptote. And then for the y-intercept, I'm going to plug in 0 for x. And so 0 for x is going to give me 0 divided by negative 16, and 0 divided by anything is 0, and so my y-intercept is also going to be 0, 0. So let's make sure that we put our horizontal asymptote here at y equals 1. We don't want to forget about that. And so now we're ready to determine where does everything go on this particular function. Now, because that horizontal asymptote is not at 0 like example 1, this time it's at y equals 1. It's a little easier for me to determine if I should go on the outsides first, either above here or below here. Well, let's just say that it's below. If it's below, what I'm going to have to end up doing is cross through the x-axis somewhere in this neighborhood. But I can only cross the x-axis or touch the x-axis at my root. And so therefore the graph cannot be down below this horizontal asymptote. It's got to be drawn above. And so my graph is going to look like this. Now, do I have togetherness at the asymptotes? The answer to that question is no, because we did not have a squared term on either of these factors. And so since we are not together, that means that on the other side of this asymptote, I'm going to have to start from below. The first place I'm going to go is to my x-intercept right there. And the next question we need to answer is, am I supposed to cross the x-axis there, or am I supposed to bounce off of the x-axis and go back down? Well, we have tangency at that particular root. And so that means we're going to go up and touch and then go back down to that next asymptote. Okay, now the last question is, where does our last section go? Does it go up here or does it go down here? And now hopefully you're starting to catch on and you're able to say that it's got to be up here, and now it's for two reasons. The first reason is if it was down here, I would pass through the x-axis at something that is not a root, and if it were down here, which it's not, I would have togetherness at the asymptote x equals 4, but I don't have togetherness at that asymptote, and so therefore for both of those reasons, the graph has got to be drawn up above that particular horizontal asymptote.